This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. This is section 5.31, logarithmic functions and graphs. Let me help explain what I mean by logs. So in section 5.1, when we opened up the chapter, 5.1 was all about inverses. And we given a function, we figured out what its inverse was. We graphically, numerically, on tables, with equations by interchanging the variables. That's what section 5.1 was. Inverses. Inverse functions, inverse graphs, one-to-one functions, horizontal line test, all that good stuff. Then we went on to exponential functions, like f of x equals 2 to the x. And we graphed this, and we found tables and equations. So here in this section, 5.3, we're going to combine these two ideas together. We're going to start off with an exponential function, and we're going to ask, what is the inverse, remember 5.1, what is the inverse of an exponential function we get from 5.2? What's the inverse of this thing? Well, I'm so glad you asked. Here's a graph of an exponential function, f of x equals 2 to the x. We've seen this before. Just want to remind you what it looked like. And then here's the graph of the inverse. Notice, all I really did was switch the input and the outputs. So we had negative 2, negative 1, 0, 1, 2, negative 2, negative 1, 0, 1, 2. I'm going to take the outputs, I'm going to make them the new inputs. 1/4, 1/2, 1, 2, 4. Hey, we might as well graph them. Let's see what this looks like. Here's the original, and here's the graph. Here's the inverse of the graph of the inverse. So here's y equals 2 to the x, and here's what we're going to call a logarithm. And a logarithm is going to be, let me compare a logarithmic function to an exponential function. The input here on an exponential function would be 3. If the exponent is 3, then you get as an output 8. We'll call that a power. 2 to the third is a power, and if you evaluate it, it's 8. Input is 3, output is 8. The inverse would switch those. And so if with a logarithmic function, if you took, say, the inverse of the exponential function, if you took the power 8, it should produce as an output 3. Remember, input 3, output 8. Input 8, output 3. It should also have the flipped domain and range. If the domain here for this exponential function is negative infinity to infinity, and the range is 0 to positive infinity, then you can expect that the logarithmic function is also going to have these two things flipped. The exponential function is always going to have a y-intercept of 0, 1, and therefore the logarithmic function is always going to have an x-intercept of 1, 0. The exponential function is always going to have a horizontal asymptote of y equals 0. Let me describe these on the graph. So going back to the intercepts. Here, there's always an intercept of 0.1, 0, 1, and then here you're going to always have an x-intercept of 1, 0. There's going to be an asymptote of y equals 0 here in an exponential function. Therefore, we're also going to have an asymptote vertically as x equals 0. That's what we get. We're just taking an exponential function and we're switching the input and the output. We're finding the inverse. So here, the exponential function had the output always was a power, and the input was an exponent. That's going to be flipped here. Logarithms answer the question, what is the exponent? Remember, the output is an exponent. So if you want to know what the exponent is on something, you can take the logarithm. Here's what I mean. Exponential notation would look like this. 3 squared is equal to 9. The exponent, I want you to get really good at identifying these three parts of this kind of an equation. We've got exponent, base, and power. The power is 9, the base is 3, the exponent is 2. So if you wanted to translate this into logarithmic notation, the base, you'd write it like this. Log, that's short for logarithmic, log of base 3, remember here's the base, base 3, power is 9, and what is the exponent? It's 2. Logarithms answer the question, what is the exponent? If you can evaluate this, then you get 2. Here, the base is 10, the exponent is 3, and the power is 1,000. If you take the log 10 of 1,000, you should get an answer of 3, because what's the exponent? It's 3. Now, these 3 stars are just indicating that most of the time, a very common log is log 10. In fact, that's one of the most common logs. So if you don't see any base written, like here the base written is 3, here the base written is 2. If you see no base written, then you can just assume that it's going to be base 10, because it's a really common log. Let's take a look at this. What's the exponent? It's -4. What's the base? It's 2. What's the power? It's 1/16. So if you take log of base 2 of this power 1/16, you will get the exponent. What's the exponent? It's -4. Here, what's the exponent? It's -4. Moving right along, we can see here, translating backwards, here's the base, here's the power, and what is all the logarithmic evaluate to? It evaluates to an exponent. So let's put this exponent here. Base, exponent, power. Moving right along, we've got base, exponent, power. 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 What do you get when you evaluate all of this? You'll get an exponent. Here, the exponent is x. And you can see this is what they look like. Base, exponent, power. Log to some base of a power is equal to your exponent. And like I said, if no base is written, you can just assume that it's base 10. Now would be a good time for me to tell you about the chemical that we use in the element that's found in bleach and in pool water. It's chlorine, and it's the element 17. The 17th element of the periodic table is chlorine. There's your audio check. Hope you enjoyed it. So the instructions here say convert each of the following to a logarithmic equation. So here, what we're going to do is we're going to take 16 is equal to 2 to the x. And you need to switch the exponent and the power. So therefore, the power goes here, and the exponent goes over here on the outside with a base of 2. Log of base 2 is equal to 16 is equal to x. One way I like to remember that is the base goes in the basement. B, take the exponent, put it over here, the log of base 10, and remember you don't need to write the base here. In fact, the book often won't, or usually won't, and most people don't. But here, log of base 10 to the 0.001 is -3. You can actually type this into a calculator. Type log and type 0.001. You should get -3, because it's telling you what the exponent would be in order to produce a power like that. Here, log of base, here's the base, it's e to the 10th power. So if you had log of base e to the 70th, if that's the power, then if you can type all this into a calculator, you'll get t. That's the exponent. Here, converting this one, we've got the base is 5, the power is 625, and if you take the log base 5 of 625, you should get an exponent of what that is. Here, the exponent goes on the outside, on the other side of the logarithm. Log of a, log base a of p is going to give you b. Exponent, base, power. Exponent, base, power. Exponent, base, power. You just got to keep on doing that. Convert each of the following to an exponential equation. So we're going to work backwards now. We're going to take this power and we're going to switch it with the exponent, and then that'll be 2 to the 5th is equal to 32, which is a true statement. Here's the base. Exponent was over here by itself because the log answers the question, what is the base? What is the exponent? And it's over here. This exponent is equal to 5. So 5 is equal to the power 32. Here, the base is a, the exponent is 8, and the power is q. The base is t, the exponent is x, and the power is m. Here, log, it's not really written, but the exponent here is of base 10, so there it is. The exponent is 2, and the power is x. I want you to do this one and tell me what you get. Here, log of base e, exponent of 2, power of a. E squared equals a. I'd like you to start the assignment 5C1. Go ahead and copy the problem list and do the first problem. I'll see you in class.